You're on mute.
Hopefully that's not how we're going to start today. So I'm going to restart here. Thanks for telling me that. That was only 1 minute in, so that's cool. So thank you so much for telling me. Anyhow, I'm going to start with the housekeeping stuff now. Good morning. You didn't hear that because I was muted. I have no idea why I was muted. Usually I come on with my video on and my audio on, so I don't know why I came on without it, but anyhow, good morning. It's good to see you all. And I was starting with the housekeeping things because on my heart, so I just want to apologize for the fiasco yesterday. What I was saying when I was muted is that, I told you that I'm a lot like you in that I like everything to be perfect, and everything's not going to be perfect, especially these days. So like I was saying with some of you, you're not even happy with straight A's. Some of you want those A pluses. And so I can relate to you so much at that level because when I set up things for you, I check them a million times to make sure everything is set up right, because I feel like you deserve the best from me. And so I make sure that everything is set up right, the times are right, that everything I need to do is set for you to take it. You have prepared for it. A lot of you study, and I don't think it's right that you study and you pour your heart into something that isn't 100%. So anyhow, I just want to apologize for yesterday. And it gives me the opportunity to just speak about things, especially now. There's a lot of uncertainty with a lot of things, but one of the things is yesterday I tried with the quiz, I tried to use the form, the Google form, and there was a myriad of different problems. So I'm going to get into that in a second, but one part was my fault, one part was your fault, one part was, who trained me on the form, and another part was just the form itself. So there were a lot of different issues. I'm going to go into that, but I want to take this opportunity right now just to talk to you about living in an unperfect world, especially now. Those of you who are perfectionists like myself, you have got to drop it down a level, because you are going to have instructors in the future that aren't going to be fair. And you're going to do everything in your power to get that A in one of your college classes, and that instructor is going to give you a B because they just don't give A's. Or you're going to have an instructor that keeps a grade book. And so they're going to grade you basically on just stereotyping you, like, well, I don't really like that person, so I'm going to give them a D, or this person, and it's sad but true. So I'm just letting you know. I may have shared this with you before, but in one of my college classes, it was actually an easy math class at UCR. I thought it was pretty easy, but I ended up getting a D in that class. The instructor was crazy. The way he tested, he didn't test anything we did. It was more of like things that he, philosophically thought about. And at that point in time, I realized that this guy's nuts. There's nothing I can do to do well in this class. So go ahead and give me the D, and I'm not even going to take it over again. And guess what? I still got my bachelor's degree. I got the D in the class. Nobody's ever looked at my transcripts since then. And so it just really doesn't matter. So it's important for you, the perfectionists out there and the straight A students, which you are, it's your perspective. Because things are not going to be the way you want them to be, and things are not going to be perfect. So keep your perspective on things, and that's my pep talk for today. With that, it's going to be easier said than done too. It's something you're going to have to work at. It's not going to naturally come to you. So you've got to work at trying to stay calm and trying to keep your perspective on things. So anyhow, I do have a meeting at 10 o'clock to talk about what happened yesterday with some people. I'm not students, with faculty and staff. Because I don't like using things that don't work. And so I have a meeting at 10 to talk about that. I want to thank you all for your 100 messages, because what happened is I bit into a cinnamon bear. and I chipped my molar, and part of my filling and my tooth broke. And so I was in the dentist chair when you were sending those 100 messages. I was in the dentist chair for 3 hours, them drilling on my teeth. So anyhow, when I came out to my car, I saw the 100 messages and I'm like, oh, great, something didn't work. So of course my heart starts beating, like I was saying not to do. My heart's beating 100 miles an hour because I'm thinking, oh my gosh, you know, they studied and something went wrong. What went wrong? So anyhow, I just want to thank you for the 100 messages. I want to thank you for those of you who sent pictures and those of you who made comments like, these problems are not letting, or they're wanting a number. You know, these problems are not letting me use less than. They're not letting me submit. So thank you for being specific, because that only helps me out, and I really appreciate that. As I was looking through things you did submit, there were some weird definitions. And so some people, you just copied the definition out of the book. So I'm concerned about your idea of how things are defined. So what I'm going to do is, if any of you would like to voluntarily take the quiz, after my meeting, I'm going to set up another quiz. And if you want to voluntarily take it, it's not going to count toward anything except my comments. Like, that isn't really what a radian is. That isn't really what it means for an angle to be in standard position, because I did not want you to get a definition out of the book. I wanted you to not look at the book, and I wanted you to give a definition to assure that you understand what I've done so far. Okay, so try to stay cognizant of what I'm trying to do and fall in line, okay? So I wanted this quiz was to see what you really know, not copy things out of the book. So I saw some weird stuff. So anyhow, if you want to take this and get some feedback from me, I'm going to pay attention to Google Classroom, and I'll set up the quiz again. And if you want to take it voluntarily just to get some comments from me, we could do that. The bottom line with everything that's going wrong is you have to remember that I'm strict, I'm structured. You know, some of you are still, you know, scared of me. A lot of you, though, I think through this distance learning have become closer to me because you feel more safe texting me. So I think that's a good thing. I wish you could talk to me more, but that's okay. I'll take text, I'll take the remind messages, and feeling closer to you feels good. But despite how I am, I will always be fair. So you have to understand that, the fact that, yes, I'm strict, yes, I'm structured, yes, I demand a lot, yes, I set a high standard, but I'm always going to be fair. Okay, I'm always going to be fair. And remember that I'm on your side. So whether you think I'm not, I am. I'm on your side. I only want the best for you. I only want you to be as successful as possible. Okay, so on Saturday, I don't have anything response from you. If any of you would like to meet with me on Saturday to ask me questions about anything, just let me know and I can set something up. You have to let me know though. All right, I think that's it. Okay, so we're still plowing through this foundational thing with 17.1. And I've given you a lot of definitions that some of you, I'm not sure. One thing for sure, I don't care that the radian is about 57 degrees. I don't care about that. What I care about the radian is that you know that it's a measure of a central angle of a circle that intercepts an arc where the arc is equal to the radius. That's what I care about. And you have to know that a radian looks like that. I don't care that it's 57 degrees. All right? Okay, so we talked about the radian, and we talked about the common angles. And then we talked, this is very, very important, and I'm not going to quiz you on this, but if you want to practice on Saturday, you have to know how to draw and name an angle in standard position. Okay, that's very, very important that you know how to do that, and that you're able to divide the quadrants into parts and be able to graph. So with that, I'm hoping you were able to do the one sheet where you're drawing the coordinate plane, You're drawing the appropriate fractional parts. You're able to draw the angle in standard position, draw an arrow to show the rotation of the ray. This is not two rays, by the way. This is one ray that's being rotated that recreates an angle. All right, so it's not two rays with the space in between. That was somebody's definition on the quiz. It's the rotation of a ray about its endpoint. We also last time talked about coterminal angles, and coterminal angles could be an infinite number of angles that have the same initial and terminal sides. And the way that we figure those out without going is we can add or subtract 360 degrees or 2 pi radians, which is, however you want to think about it, 1 full revolution. Now, I don't think I did. I think I did one example and then I tried to hurry, with that. So I'm going to continue with coterminal angles. And then we're going to talk about converting from the degrees and radians to degrees. But I'm just going to tell you that normally, if you're working with radians, do not convert to degrees. When you're working with degrees, don't convert with radians. So just like, if you think about when we work with fractions, we want to work with fractions. We work with decimals, we work with decimals. It's the same concept in general here, that when you have something in radians, work in radians. It'll be the easiest thing, all right? If it's in degrees, work in degrees. Don't convert back and forth, even though I'm going to show you how to do that today. There are special times when you want to do that. You normally don't convert back and forth. So let's get started here. I think that I did 23 degrees. So can somebody just chime in? Did I do an example for 23 degrees as far as coterminal angles go? "23 degrees, someone? Hello?
Yeah, you did.
Okay, what about 420 degrees? $420?
No.
Okay, and then I think I did negative pi over 9 radians. Okay, so let's do a couple more examples. So once again, we're finding 2 positive coterminal angles and 2 negative coterminal angles. And let's take a look at a big angle this time. So this angle obviously is more than 1 revolution. So if you had to draw and name an angle, can you guys see? Okay, can somebody give me some feedback on this? Can you guys see the boards or no? Yeah, okay. So for this one, $420 degrees. What we could do with this now, in the last time you saw me do a problem, it was an angle that was less than 360. So with this 420, I don't have to add 360. I could still get 360, right? So if I subtract 360, I get 60 degrees. And then to get another positive one, I can add 360. So that would be what, 780? Do not forget to put the degrees. Remember what I said last time. If you forget to put the degrees, you mean 780 radians. And so that means you mean 780 of these. So that's not what you mean. So, all right, as far as the negative one goes, if we take 420 and we subtract 360, that's not going to give us a negative one. That gave us this. So we would already have to double it. So if you double this, we would subtract 720. So that would be a negative 300 degrees. And if we wanted to find another one, we would take 420 and we would have to triple that. So 720 tripled would be negative 1080. So that would be a negative 660. All right, so anyhow, the problems are a little different. It's not always, when you want to find a positive, you add 360. When you want to find a negative, you subtract. Depends on the size of the angle, what you do. So they're not all done the same. Okay. All right, I'm going to do one more of these coterminals with a radian angle, 2 pi over 3 radians, and then we're going to move on. All right, so we want positive coterminal angles and negative coterminal angles. So with this one, if we add 2 pi, we can get one. Now, I was saying last time that welcome to the fraction world, because you will have a bunch every day of fractions. So you got to be really comfortable with these now. So get a common denominator. Last time you saw me show all the steps, but from here on out, you're going to see me skip steps. So I'm just going to, if you look at this right now, this is 2 pi and 6 pi. So I'm not going to write that extra step. I'm going to just say 2 plus 6 is what, 8 pi over 3 radians. And if I want to find another one, you take 2 pi over 3 and double 2 pi would be 4 pi. So same thing, get a common denominator. Once again, I'm going to skip the step. This is 12 pi plus 2 is what? 14 pi over 3. Okay, as far as the negative ones go, you take your 2 pi over 3 radians and you subtract 2 pi. You still need a common denominator. So with this one, you have a negative 6 pi and 2 pi. So a negative 6 pi and 2 pi is negative 4 pi over 3. And one more would be 2 pi over 3 minus 4 pi. So that's a negative 12 pi over 3, and 2 would be negative, what, 10 pi over radian. All right, any questions about finding coterminal angles? Pretty easy stuff. The next objective is converting between degree measure and radian measure. And then I'm going to do a word problem. Then I'm going to start the new lesson that time. Question? All right, if you want to convert to degrees, from degrees to radians, you know what, I'm just going to show you some examples because I don't want you to memorize this. It's just common sense. So let's take a look at some examples. So this is going to be from degrees to radians. So if they give you 20 degrees, think about it. We can multiply by 1 without changing the problem, right? So if I want to get rid of degrees, couldn't I cancel the degrees if I put 180 there? And what's equivalent to 180 in radians? Pi. So the whole thing here is we're just multiplying 20 degrees by 1. Because 180 degrees is equivalent to pi radians. So look what happens here. Those degrees cancel. We can cross cancel. Remember, this is 20 over 1. Those zeros cancel, and 2 goes into 18 9 times. So this is equivalent to pi over 9. So how about negative 60 degrees? We want to convert it to radians. So you have negative 60 degrees. So we want to multiply by 1. We're just going to keep using this because we liked it. So 180 degrees is equivalent to pi radians. That fraction is 1. We can multiply anything by 1 and not change the problem. I can write equal. So once again, we can cancel the degrees. Excuse me, we can cancel the trailing zeros. And 6 goes into 18 3 times. So we have a negative in front, negative pi over 3. So negative 60 degrees is equivalent. Let's do a bigger one. Negative 540 degrees. That's a big negative angle. So it's more than 1 full revolution clockwise. And so we're just going to do the same thing. We're going to take 180 degrees and pi radians. That fraction is equivalent to 1. So I can cancel the degrees, cancel the trailing zeros. And then we have 54 and 18. So 9 times 6 is 54, right? So I think 9 goes into both. So 9 times what is 18? 2. 9 times what is 54? 6. Oh, look at that. Cancel again. 2 goes into itself once. 2 goes into 6 3 times. So this ends up being just negative 3 pi. Quadrantal angle. If you were asked what quadrant that's in, it's quadrantal when it lands on one of the axes. So yeah, nothing really to memorize, just use common sense. If you want to cancel degrees and use 180. This, by the way, before the Common Core state standards, this was a California standard. It was a power standard. And so this was heavily focused on for students to make sure that students absolutely know how to convert. Okay, now let's go the other way now. Let's go from radians to degrees. So let's say you have pi over 8. And let's say that they don't write anything. You do know that radians is implied, right? So radians is implied. So what we're going to do is we're going to multiply by 1 again. And I'm going to write the word radian here because it's going to help us. And now, instead of putting 180 degrees on the bottom, I'm going to put pi radians on the bottom. So what's equivalent to pi radians in degrees? 180, right? So we're still, that's 1. So we're multiplying by 1, which doesn't change the angle. So now we can cancel pi, we can cancel the radians. What goes in 2? 4 might go into it. 2 goes into both. So 2 times what is 8? 4. 2 times what is that? 90. Yep. So I'm going to do it again. 2 goes into 4 twice. 2 goes into 90 45 times. So our answer would be what? 45 over 2 degrees. And that makes no sense whatsoever. So we would want to, you're like, that's really weird. And it is weird. We would want to write this as a decimal for it to make sense. So this is 22.5 or 22.5 degrees. Let's try another one. Hopefully, if I go too low, let me know and I'll move the screen. Let's try -7 pi over 12 radians. So once again, whether they put radians or not, I'm going to put radians. And I want to cancel the radians, so I'm going to use pi radians on the bottom. And what's equivalent to pi radians is 180 degrees. So now I can cancel the pi's and I can cancel the radians. And 12, does 12 go into 180 evenly? No idea. Can somebody tell me what's 180 divided by 12? I think it's going to go in evenly. So 180 divided by 12 is what? Can somebody help me out, please? I don't have it written down.
15.
15?
Yeah.
Okay, thank you. So 15 times -7 would be what? -105? Okay, now, let's do this problem. I don't have it on my sheet. What if you had 1 radian? When we're looking at our book, we want to convert 1 radian to degrees. Couldn't we say that pi radian is equivalent to 180 degrees? And couldn't we do the same thing we're doing? Now, check this out. You can't cancel pi. There is no pi. But you can cancel the radian, but there is no pi. So isn't this 180 degrees divided by pi? So now put that in your calculator and tell me what you get. I'm listening. I don't have it written on my paper.
57.29577.
See that? So this is about 57.3 degrees. And we don't, like I said, we don't care about that. So we don't care that 1 radian is 57 degrees, but I just wanted to show you that you don't have to trust the book. 1 radian is 57.3 degrees, but we don't care about that fact. We're never going to use that. If you ask me 5 minutes from now what 1 radian is in degrees, I have no idea. I just know and care that it looks like that. All right, one more problem, we'll go on. I'm not going to get too heavily into this because we will focus on this in pre-cal. So, but I do want to expose you to it. I do not think I assigned any applications in this because, like I said, we're going to cover it in pre-cal. So, but I do want to show you it. All right, you guys have to pay attention to Google Classroom because today, other than saying if you want to meet with me on Saturday, I'm not telling you when this assignment's due. I'm not telling you when we're going to take an exam on this. So all I can tell you, it's not going to be on Monday, but it's going to be soon after that. So pay attention to Google Classroom and on these dates for exams and assignment dates. So if you're looking at your book, if you could look at page 830, problem A. All right, so I just want to show you the arc length formula. Not going to write it all out. This is what it looks like. So remember, S is the arc length. And it's measured in inches, feet, yards, centimeters, millimeters. The radius is also measured that way. Feet, inches, centimeters, yards. In this formula, this is the angle, and the angle must be in radians. So something for pre-calc, can only use this formula if the angle is in radians. That means that if you do get an angle in degrees, this is one time when you have to convert. So you cannot put degrees in this formula. It will not work. So you must convert. If they don't give it to you in radians, which they probably won't, it's a real life problem, you have to convert it to radians. Now, one thing about trigonometry is they give you formulas, but you can rewrite formulas to create new formulas. So let's say you have 100 formulas. You really have 500 because they can all be rewritten different ways. So let me explain what I mean here. You might see the formula like this, but if you divide by theta, you could get R is equal to S over theta. So there's another formula when you solve for R. If you solve for theta, you can get S over R. So from this one formula, you can have these different formulas depending if you want to solve for the arc length, if you want to solve for the radius, or if you want to solve for the angle. And you will use all three of these in trigonometry. So you can rewrite formulas to meet your need. All right, let's take a look at this problem here. It's about the sun. I'm going to read it really quick. You can read it over if you want. A point on the sun's equator makes a full revolution every 25.38. The sun has a radius of about 432,200 miles at its equator. What is the angular velocity in radians per hour of a point on the sun's equator? And then they're asking, what is the distance around the sun's axis? What distance around the sun's axis does the point travel in 1 hour? How does this compare with the distance of about 1038 miles traveled by a point on the Earth's equator in an hour? There's a lot of stuff here. So you might want to read it 100 times and see if it makes sense. So this is the arc length formula. Let me talk about angular velocity real quick. All right, velocity is speed, right? What does angular mean? Angle, measure through an object. Turns in a given time interval. All right, so it's the angle measured through an object turns in a given time interval. Left a word off here, which. There, that makes sense. An angle measured through which an object turns in a given time interval. There you go. That's better. I was looking at that like this crazy. All right, so in some of your science classes, you've had to do some conversions. And so in this case, we're going to have to convert because the problem's asking for radians per hour. So this is what we're going to do. So in the problem that we have 2 pi radians, right? A full revolution in 25.38 days. Well, this conversion, what we need to know is that 1 revolution is equal to how many radians? So 1 revolution is equal to 2 pi radians. That's what we have here. So that's how I got this. So from the reading, they're talking about 1 revolution, which would be 2 pi radians per 25.38 days. All right, so now to do this conversion, we want to convert, we don't want radians per days, we want radians per hour. And so what we have to do is get rid of days. So what do we know over here? Well, we know that 1 day is equivalent to 24 hours. That's just a fact that we know. So that's going to be our conversion factor. So now what happens is this days cancels, and we can come up with radians per hour. And if you put this on the calculator, I'm going to do it for, we can cancel 2 here. So 2 can cancel, get 1. 2 goes into that 12. So this would be pi divided by 12 times that. Can somebody give me that number, please? 12 times 25.38. 25.38 times 12, somebody?
304.56.
Thank you. And so that's approximation. So if you put that in the calculator, you should get about 0.1032 radians per hour. Okay, so now we're ready to use the formula. So now you can take your arc length formula, which is S is equal to R theta, and we can find the arc length. So what? So what is our radius? In the reading, they said it was 432,200. Our angle in radians per hour is this, 0.01032. We didn't round too much, that's good. And so we can find the arc length. So if you put that in the calculator, we get an arc length of about 4,460. And so let me just put it all together for you. The point travels 4,460 miles around the sun's axis in an hour. This is 4 times farther than a point on the Earth's equator traveled at the same time. I'll say it one more time. Okay, the point travels about 4,460 miles around the sun's axis in an hour. This is 4 times farther than a point on the Earth's equator travels at the same time. So anyhow, I just wanted to expose you to the arc length formula and talk a little bit about angular velocity, but you will get more of this in pre-cal. I'm not assigning any problems with this. So just to let you know, the assignment, which is not up yet, it is 833 through 836, 1 through 14 all. So 833 to 836, 1 through 14 all. Actually, this is up, right? Because we're still, I'm thinking that, you know, this is a new lesson, but we've been talking about this lesson. So basically, you should be able to do everything now. So hopefully you've been working things as we've gone along, the parts, and this is going to be due pretty soon. I don't have the due date for it, but it is up, the assignment. So this is all the different pages, all the drawing and the naming the angle, all the practice AB, there's evaluate problems. Make sure and stay focused though that the exam being online, it's always going to look like the evaluate on the My HRW. So you always want to practice those problems and make sure that you're most familiar with those problems. All of these other problems are just extra practice to solidify the concepts that we're going over. All right, So I have a little bit of time, so I want to get into 17.2. Why is words like that? Okay. All right, in 17.2, it is important that you do the Explorer. The Explorer should look very familiar to you. It should look like what you did in Miss Fresco's class in a few week period. It's everything at once. As far as SOHCAHTOA, do you remember that mnemonic device? And we're looking at common angles of a unit circle. So I'm actually going to go through this right now because this is super important, but make sure you do the Explorer. All right, so just to review what Ms. Fresco went over, if the angle theta is an acute angle, and you should know what acute means. Acute means greater than 0 degrees or radians, less than 90 degrees, or pi over 2 radians. In a right triangle, then these facts are true, that the sine of theta is equal to opposite over hypotenuse. And you should memorize them in this order. There's a reason for memorizing them in this order, other than just the mnemonic device. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So there comes the name SOHCAHTOA, which means nothing in math. It's just a mnemonic device to help you remember this, that this is sine SOHCAHTOA. So it's just a memory device. And the way this triangle looks, it must be a right triangle, by the way. It can't be oblique. Oblique meaning that there's no right angle. So it must be a right triangle, and its whole definition depends on where the angle is. So for example, if your angle was down here, you put your finger on the angle and determine this information. So when you put your finger on the angle, this would be the hypotenuse, which nobody messes up on the hypotenuse. It's the longest side. But the adjacent side to this angle would be here. And opposite the angle would be that side. Now, that's not the case if your triangle looked like this. Okay, that is no longer the adjacent side. So this is what people get confused about, is you have to derive this information from the location of the angle. So in this problem, everybody's going to get the hypotenuse right. But if you put your finger on this angle, the side adjacent would be this side. The angle would be that. So it's very important to stay cognizant to the angle location. You know, remember how long I've been teaching this now. So every year I see students make the same mistake. So I know what to stress when I'm teaching. So I'm just letting you know, students make a lot of mistakes on this. So make sure you always stay cognizant of the location of the angle. Let's do one more. Say it looks like, the triangle looks like this. So there's your right angle. And let's say that theta is here now. Well, like I said, people will get the hypotenuse right. But now when you put your finger on the angle, what side is adjacent? It would be this side. And what side is opposite would be this side. You notice all of these pictures look different depending on the location and the angle. All right, anybody want to ask me about this? Super critical that you know this. Okay, so this, the reason why Ms. Fresco taught this was because she was focusing on defining the trig functions using triangles, particularly right triangles. But there's another way to teach trigonometry, and it's using the unit circle. So two different methods, and we're going to look at both. So this is looking at defining the trig functions using right triangles. And now I want to show you looking at these trig functions using the unit circle. By the way, if any of you know any honors geometry students or just geometry students that want to take period 0, if you could just forward their name or give them my email or forward their name and student ID, I can put them in the class. There are advantages for taking period 0. And one of those advantages is I don't know how many honors classes I'll be teaching. If I only teach one honors class and it's period 0, then they won't be able to take me or take, honors. So usually there's 2 classes, but there's also an issue if there's, if it's offered like 3rd period and there's a conflict with classes, you have to choose between which class. So if you guys know anyone who wants to take the period 0, or for sure want to have me and make sure they're prepared for calculus, send them my way. I am enrolling students. So I'm enrolling the students. There's been some rumors. Ms. Fresco even told me, she goes, yeah, they told the students that you weren't going to offer period 0. I think with all this, the way school's going to look like coming up in the future, the principal called me and specifically talked to me about period 0. So we can't offer it. So if you have any friends that are interested in that, make sure you let me know. Okay, and looking at the unit circle, I'm going to draw a big picture and I recommend you do the same. I have some beautiful magnets at school to do this, but I left them at school, so I didn't bring everything home with me. So this is the y-axis, x-axis. And like I said, the reason why this is called the unit circle is because this radius is 1. Unit means 1. Okay, so let's go over the quadrants really quick. So you should know that this is quadrant 1. We've talked about this before. Quadrant 3 and quadrant 4. More importantly, though, you should know that in quadrant 1, the ordered pairs are positive, positive. And in quadrant 2, x is negative and y is positive, and we're looking at ordered pairs. In quadrant 3, you have a negative, negative, and in quadrant 4, you have a positive, negative. So that's very, very important. You don't get mixed up with x's and y's. So these points, normally you see them as x, y, right? Well, now we're going to look at as cosine theta and sine of theta. So in other words, when I talk about x, I'm talking about cosine of theta. When I talk about sine, so don't get them mixed up. Here's one way to remember it. X comes before Y in the alphabet, just like C comes before S in the alphabet. Now, this right here, you guys, this right here is saying that this is the cosine of an angle. And this is the sine of an angle. So in the future, you can have anything for the angle. You could have beta, alpha. Sometimes you're going to see x for the alpha, for the angle. Right now in trigonometry, in pre-calc, we're dealing with double angles. So we're looking at 2x. We're looking at triple angles, 3x. And we have all these different formulas. We have power reducing formulas. We have double angle formulas. Just know that those are angles. And so what? Well, we want to look at the common angles, and I may quiz you on this. So make sure that you know this. I don't care about the other quadrants because those will be easy to come up with. But if I break this into, okay, let me just show you what I'm doing first. So first of all, what I'm doing is I'm showing 3 different pictures superimposed on each other. So I'm going to show you 6 parts. I'm going to show you 4 equal parts. And then I'm going to show you 3 equal parts. So as soon as I finish this, we'll be done for today. But anyhow, these are all going to be superimposed on each other, so I don't want you to get confused. So in this picture right here, that first angle that you see is going to be that. In this picture, this angle is going to be that. And in the last picture, you're going to see that angle. So it's those 3 pictures put on top of each other. Now, what happens here, let me talk about degrees first. So this angle that has no rotation of a ray is going to be 0 degrees. And this rotation right here is, it's going to be easier to see with radians. This is going to be your 30-degree angle. This is going to be 30 degrees. This is going to be your 45-degree angle. And this is going to be your 60-degree angle. And up at the top with Y is your right angle. I'm not going to draw it. And from all these, this is where Miss Fresco got those right triangles. So we're not going to look at that, but I'm just telling you that if you draw a line segment straight down, you'll see what Miss Fresco did when she was developing this with right triangles. Okay, now, in radians, this would be 0 radians. This would be, if you look at this, pi over 6, right? That's 6 parts, so it'd be pi over 6 radians. This one is broken into 4 parts, so it'd be pi over 4 radians. And the other one is pi over 3 radians. And this would be pi over 2 radians. So you must know these, like walking, like breathing. You don't think about walking or breathing. You must know these. So more importantly, what goes with this and what Miss Fresco did, and I'm going to stop in a minute, is she came up with the ordered pairs of these points. So each one of these angles has a point on the unit circle. And this point is right 1, 0. So if I asked you, what's the cosine of 0 degrees, you would say the cosine of 0 degrees is 1. What's the sine of 0 degrees? What's the sine of theta? It'd be 0. What's the cosine of theta? 1. Okay, So cosine of theta is 1, sine of theta is 0. So over here, this ordered pair is square root of 3 over 2 and 1/2. This ordered pair is square root of 2 over 2 and square root of 2 over 2. And let me erase this. This ordered pair is 1/2 and square root of 3 over 2. And this ordered pair is 0 up 1. Now, I want hand. Watch. See how my hand fits on here? If I bring this finger down, I can get these ordered pairs. So first of all, look at all these. All of these except for 0 and 90, all of them have a denominator of 2, right? Okay, watch my hand. If I bring this down, you see this square root of 3 over 2 and 1/2? If I bring my middle finger down, I can get square root of 2 over 2 and square root of 2 over 2. And if I bring this finger down, I can get 1/2 and square root of 3 over 2. So that's really exciting that you can hold up your left hand and come up with those ordered pairs. I'm going to stop right now, but I'll come back to this. I did want to get that in because it's cool. A student showed me this one time that you can use your hand to come up with the ordered pairs. So anyhow, I hope you have a good day today. Let me know if you want to get together on Saturday at 9. Pay attention to Google Classroom when things are due. And we'll continue 17-2 with the unit circle, and we're going to get into some cool stuff. So anyhow, have a great day. All right, you can hang out with me if you want. I'm going to turn off the recorder though.